Today we're going to be having a look at solving simultaneous equations. There's going to be a lot of examples by me on the board. Hopefully most of you have seen this topic before and it will serve as revision, but I will work through plenty of examples on the board to help you try and gain an understanding of the topic. Just to start with, a starter activity, just solving some simple equations. 7x equals x plus 42. Solve. Get x on its own. X equals a value. 4x plus 3 equals 5x. Get x on its own. Find the value of x. 4x minus 3 equals 12 minus x. X on its own. Get a value of x. And then finally, 6 bracket 3x plus 2 equals 3 bracket 4x plus 6. Find the value of x. Get x on its own. Write those examples down, have a go at them, and then we'll come back and we'll do some solutions for you. Right, so let's work through some solutions here. 7x equals x plus 42. What do? We want to get x on its own. We subtract x from both sides. So minus x from the left hand side, minus x right hand side, 6x equals 42. What do we do to get x on its own? Divide both sides by 6, so x equals 7. Second example, 4x plus 3 equals 5x. We want to get x on its own. Right, okay. Let's take away 4x from both sides then. Minus 4x from the left hand side, minus 4x from the right hand side, which means you've got 3 equals x. Job done. X equals a value of 3. Okay. Slightly longer examples. 4x minus 3 equals 12 minus x. Got to get x on its own. Add x to both sides. Get all the x's on the left hand side. So add x to the left hand side. Add x to the right hand side. 5x minus 3 equals 12. 5x minus 3 equals 12. What can we do then? Add 3 to both sides. So 5x equals 15. What do we do to get x on its own? Divide both sides by 5. So x equals 3. Okay, this one here, we've got 2 brackets. Well, there's a couple of different ways we could do this. Probably about the simplest way is, well, we've got 6 multiplied by a bracket and 3 multiplied by a bracket. I'm going to divide both sides by 3, which means that on the left hand side I'm left with 2, 3x plus 2, so the bracket remains the same. On the right hand side I'm just left with the contents of the bracket, 4x plus 6. I've divided both sides by 3. So, the left hand side, multiply that bracket. Right hand side stays the same. Now I've got something that should be more familiar to you. Subtract 4x from both sides. So 2x plus 4 equals 6. Subtract 4 from both sides. So 2x equals 2. 2x equals 2. Divide both sides by 2. X equals 1. That's my 4 solutions, ladies and gents. Hopefully that should be a nice little bit of revision for you about solving equations. Solving an equation, getting the variable on its own. The variable in all those examples has been x. Solve means get a value for x. X equals something. Now, simultaneous equations. What's different about them? 2 different equations, but we've got a complication here. We've got 2 different variables. In this example here, we've got x's and we've got y's. Now, the method that you know for solving an equation, getting x on its own, or indeed getting y on its own, we can't apply it to either of these equations. What we have to do is we have to work with the two equations together, simultaneous equations. We're working with them at the same time, simultaneously. We've got to get a value for x, but we've also got to get a value for y. So, the method that I'm going to run through today should be familiar to most of you. Certainly the method that I tend to teach is an elimination method. So, what we're going to look at is what happens if we combine those equations. If we combine the x's, combine the y's, combine the numbers. And the way to look at this is we title this equation 1, we title this equation 2. So, what happens when we add equation 1 to equation 2? Add equation 1 to equation 2, and you'll see the way I've written these with the x's and the y's and the numbers aligned. So if you add up the x's in equation 1 and equation 2, 3x plus x gives me 4x. We add up the y's plus y and add it to a negative y, so a positive y added to a negative y, what does that give me? It gives me 0. I've got rid of the y's. I've eliminated the y's. 19 added to the 1 gives me 20. And we now formed a new equation that is more familiar to us. Yeah, we've got rid of those y's by adding equation 1 to equation 2, adding the x's, adding the y's, adding the numbers. We've got rid of those y's. 4x equals 20. What do we do to get x on its own? Divide both sides by 4. So x equals a value of 5. So already we've got one of our variables a value of 5. X equals 5. But we've still got to find the value of y. So this goes back to some basic algebra now. We've got a value of x. Let's put that value of x equals 5, in equation 2. Equation 2 is a nice little simple equation, not many numbers in that. So if we substitute a value of x of 5, so that means 5 minus y equals 1. Okay? We're trying to find the value of y. That's something we can do. We can say minus 5 to both sides, minus 5 to both sides, so minus y equals minus 4, so y actually equals 4. Minus y equals minus 4, y must equal 4. Have we got a value of y? Have we got a value of x? Yes, we have. Have we done what the question asked us to do? Yes, we have. And we can actually check that, and we can check this each time, and I will do it for you this time. What happens if we take this value of x and we take this value of y and we put them back into equation 1? 3 lots of x is 15, plus the value of y, which is 4, equals 19, which is what equation 1 says. So we found the value of x, we've used that to find the value of y, we've checked it back into one of the equations, and those two values actually work in the equations. That's what it's all about, ladies and gents. So, another example. Fairly straightforward again. Label it equation 1, label it equation 2. We've got a minus 2y, a negative 2y, and a plus 2y, a positive 2y. Same type of scenario as the last question. Let's just add the equation 1 and equation 2 together, and that will get rid of my y values. So, equation 1 added to equation 2, 3x plus x gives me 4x. negative 2y, positive 2y gets rid of my y's. 14 plus 10 gives me 24. Divide both sides by 4, x equals 6. Okay, I've got a value for x. Let's go over, get my value for y. Now, we know how to do this now, we've got to do a bit of substitution. So, this is an easier equation to work with rather than 1. 2 is an easier equation to work with, so if I substitute my values in, the value of x is 6, plus 2y equals 10, minus 6 both sides, 2y equals 4, so y equals 2. Have I got two values, one for my x, one for my y? Yep, I've got y equals 2, I've got x equals 6. Have I done what I've been asked to do? Yeah, I've done that. Absolutely fine, no problems at all. We can substitute those values back in. We could substitute them into equation 1 here. 3 lots of x, 3 lots of 6 is 18, 2 lots of y is 4, 18 take away 4 is 14, so it does actually work again. Okay, I said to you there's going to be a lot of examples today. So, got a little bit of a problem here, haven't we, with this one. If we add those two equations together, 5x plus x is 6x, 2y plus 2y is 4y, 19 plus 15 is going to give me my 34. So if I add them together, I'm not actually going to be getting rid of either the y's or the x's. Label them equation 1 and equation 2. What do we have to add? Our aim is to get rid of either the x's or the y's. Got the same number, the same coefficient in front of the y's. Let's just do this. Let's just say equation 1 take away, subtract equation 2 this time. So 5x take away an x gives me 4x. Excuse me. 2y take away 2y. Now that gets rid of my y's. 19 take away 15, subtract 15 gives me 4. 4x equals 4, so x equals 1. Got one of our variables, haven't we? So these two equations, we don't have to add them together, they could be subtracted. Okay? X equals 1. Substitute my x equals 1. Let's substitute it into here, into equation 2. So an x is 1 plus 2 lots of y equals 15. Take away 1 both sides. 2y equals 14. Y equals 7. Y equals 7, x equals 1. Have I got my two values? Yes, I have. Quickly substitute those back in. Y equals 7, 2 lots of y is 14, 5 lots of x is 5 times 1, so that's 5. 5 plus 14 does equal 19. So those two values do work for one of my equations. Okay? So, these two equations, don't forget we're trying to find the value of x, we're trying to find the value of y. Can be added together the equations to help us eliminate one of those variables, either the x's or the y's, but we can subtract them, as this example has shown us. Okay, similar type of example again. We'll go through this a little bit quicker. Equation 1 and equation 2. Let's do equation 1, take away equation 2. Want to get rid of either the x's or the y's. It's going to have to be a subtraction this time. 5x, take away 2x is 3x. Y, take away y, gets rid of my y's. 20 take away 11 gives me 9. 3x equals 9, x equals 3. Dividing both sides by 3. Substitute x equals 3 into, let's do it in equation 2. So 2 lots of 3 is 6 plus y equals 11. So y equals 5. Let's just substitute both of those values back into equation 1. 3 lots of 5 will give me 15 plus 5 gives me 20. Yeah, they work. Okay. Right. Okay. Straightforward adding or subtracting of the two equations. When the coefficients, so the numbers in front of either the y's or the x's are the same. Okay, so that's the simple, more simple type of example, solving by elimination simultaneous equations. It gets complicated, as I'm sure you'd expect, and some of you will know already. What happens when the coefficients in front of either the x's or the y's aren't the same? Then we've got to do a little bit more work. I'm going to go through some examples of this now. Hopefully most of you will be able to do these more simple examples where it's just adding or subtracting the two basic equations. The next step on is the slightly harder examples. You might have to pause the presentation and work back on what I've told you, but I will work through these examples now. Okay, right, so this example. Neither the number in front of the x's nor the number in front of the y's, the coefficients, are the same here, so we can't just add or subtract those two equations to get rid of the x's or the y's. So we've got to do a little bit more work. Start off by saying equation 1 and this equation 2 again. What we're going to work on doing is we're going to create a situation where either the x coefficients in the two equations or the y coefficients in the two equations are going to be the same. And then we can go back to our simple method of just adding two equations or subtracting two equations. What's going to be easiest here? I've got a 2 in front of the y there, I've got a 1 in front of the y there. What I'm going to do, ladies and gents, is I'm going to say equation 2, I'm going to multiply it by 2. So all of equation 2 there, I'm going to multiply by 2. That means 2 times 2x gives me 4x. 2 times a negative y gives me minus 2y. 2 times 6 gives me 12. I've now created effectively a new equation. So I'm going to call that equation 3. So now I've got a 2 in front of the y here, I've got a 2 in front of the y here. In equation 1 and equation 3, I've got a 2 in front of the y. So hopefully you can see that takes us back to the situation that we had in the more simple examples. Now what do? I add equation 1 to equation 3. That will get rid of my y terms. So equation 1 plus equation 3. 5x added to the 4x gives me 9x. 2y and a negative 2y gets rid of my y's. 24 added to 12. 24 added to 12 gives me 36. 9x equals 36. Divide both sides by 9. X equals 4. Okay? So, I didn't have a coefficient in front of the x or the y that was the same. So I had to create a new equation. I did that by multiplying equation 2 by 2. So I created a new equation. I've added equation 1 to equation 3, and that has allowed me to get a value of x. So we've now got a value of x. So substitute x equals 4 into, let's go into equation 2. Two lots of 4 is 8, minus y equals 6, minus 8 both sides, so minus y equals minus 2, so y equals 2. So I've got my value of y, I've got my value of x, so very quickly, 5 times x is 20, 2 times y is 4, 20 plus 4 gives me 24, so those two values work when we substitute them back in. New example, haven't got coefficients, numbers in front of the x's or the y's that are the same again, we're going to have to do a little bit more work. And this time we're going to have to do significantly more work. Equation 1 and equation 2 again. Right, now, what could I do to make the numbers in front of the y's or the numbers in front of the x's the same? So I'm going to do this, ladies and gents. I'm going to say, I'm going to multiply this equation 1 by 2. So equation 1 becomes 8x plus 6y equals 54. New equation, call it 3. Then going to do equation 2 multiplied by 3. 15x plus 6y equals 75. Equation 4. What have I done? I've created equation 3 and I've created equation 4, and I've now got a coefficient, a number in front of the y that is the same. I've got 6y and I've got 6y. They're both positives, so I'm going to have to do a bit of subtraction. Now, the way I'm going to do this is I'm going to subtract equation 3 from equation 4. So I'm doing my subtraction upwards, which you're not used to. It shouldn't be too difficult for you. So I'm saying equation 4 subtract equation 3. So 15x take away 8x gives me 7x. 6y take away 6y gets rid of my y's. 75 take away 54, subtract 54 gives me 21. So 7x equals 21, divide both sides by 7, x equals 3. Okay. So I've got a value of x equals 3. Same as we've been doing. Sub x equals 3 in equation 1. So 4x plus 9 equals 27. Minus 9 both sides. 4x equals 18, is that right? Yeah. Which means that x equals 4.5. Oh, sorry, that's y, isn't it? Hold on. Yeah, got that the wrong way around, didn't I, ladies and gents? Sorry. Let's just go back on that. Good job I thought about that. Right. We've got x equals 3, not y equals 3. So sub x equals 3 into equation 1. 3 times 4 is 12, plus 3y equals 27, minus 12 both sides. And so I've got 3y equals 15, so y equals 5. That's better. So now I've got y equals 5 and I've got x equals 3. Okay. We'll do one last example. Don't forget you can pause the presentation and go through the working if I've gone too fast for you. One last example here, ladies and gents. Equation 1, equation 2. haven't got the same coefficients for equation 1 and equation 2 for x and y. So I'm going to take equation 1, multiply it by 3. 15x minus 12y equals 69. So I'll create a new equation, we'll call that 3. Equation 2 multiplied by 2, so 4x plus 12y equals minus 50. New equation. So I've now got positive 12y, I've got a negative 12y. What can I do? To eliminate either the y's or the x's there, add the two equations together. So 4 plus 3, 4x plus 15x gives me 19x. 12y added to a negative 12y gets rid of my y's. Minus 50 added to 69 gives me 19. So x equals 1. Okay, so I've got a value for x. Same thing as I've been doing. Got to substitute. X equals 1. We'll put that into equation 1 there. So 5 minus 4y equals 23. Minus 5 both sides. Now, that's got a bit complicated there, isn't it? Got minus 4y equals 18. So y equals a negative 18 over 4. So let's just think about that. Can that be right? Or have I made a mistake? Got a value of x equals 1. I'm quite happy with that. So 5 take away 4y equals 23. Take away 5 from both sides. So minus 4y equals 18. So y equals 18 over 4, but it's a negative. So y equals minus 4.5. So we're going to have to substitute that back in and see if that works. That's quite complicated, isn't it? So let's have a little look at that. Let's substitute those two values, x equals 1 and y equals minus 4.5, back into equation 2. So that would be, let's change the colour, 2 plus, and it's 6 times this, 6 times 4.5. So 6 times 4.5 is going to give me 27 minus 27, so it's actually going to give me a minus 27, so it's minus 27 equals minus 25. 2 minus 27 does give me minus 25, so whew, yeah, it does work. What this is showing to you is it doesn't have to be a whole number solution. Right, so I've done 3 harder examples there. I've done, I think it's 4 or 5 more simple examples. It is all about get your x's or your y's on their own. The more difficult examples, you've got to do something with the equations to start with, and the more simple examples, you are just adding or subtracting the two initial equations. Okay, don't be scared of these, it's just about being methodical and working through. Find one of your variables by eliminating the other, then find your other variable by substituting back into one of the original equations. So that's the presentation on simultaneous equations. I've said to you already a couple of times during the presentation, if you find something a little bit complicated, stop the presentation, go back and have a look at it again. Okay, you'll get plenty of opportunity to practice with tasks. So take the opportunity to practice. Make sure, say it again, that you are methodical in your solutions, working through your solutions. Right, hope that's been helpful. Thank you very much for your attention. And that concludes today's presentation.